This part 3 video is going to cover how to set up a local backend for psf-bch-wallet to talk to. There's a lot of advantages in doing this. So first, in order to understand the advantages, you need to understand the local versus the global backend. And the real explanation, I'm going to just cover the highlights here, but the real explanation is on cachestack.info. Go to the introduction. It'll introduce the cache stack, the Web 2 cache stack, and then how it evolved from Web 2 to Web 3 using IPFS. And this introduces the idea of a local backend and a global backend. And so the idea is that a local backend is a very small, lightweight REST API that your front-end applications can talk to. And that local backend can bridge IPFS to talk to one of many global backends. And the global backend needs like a full desktop because you have to run a couple indexers, a full node, a REST API, and an IPFS node. That makes up an entire global backend. It can be pretty heavy computationally, but even a small budget computer like a Raspberry Pi can run the local backend. It's very small and lightweight. So, as I said, small computers like the Pi 400, which is one of our hardware references, can run the local backend. So that's a $100 computer. It's ubiquitous. It's internationally available, and so that is a great way to get cryptocurrency to the masses. And the local backend is a censorship-resistant way to access the infrastructure required to run cryptocurrency applications. And it does it through IPFS. And so I don't want to go into details here, but the main difference, the main sort of magic thing that makes this better or work where it didn't before, is the notion of content addressing, which is an idea introduced or largely championed by IPFS, whereas the Web 2 is location-based addressing. So the internet that we've had for the last 30 years has been built around location-based addressing. IPFS really championed this idea of content-based addressing, and that's the magic. That's the difference between Web 2 and Web 3. Content-based addressing allows for censorship-resistant sort of data access and communication over the internet that Web 2 does not allow for. And so this is a direct application of those principles in a way that actually saves money and improves availability and access to do commercial things on the blockchain. So local and global backends, they distribute the cost of running infrastructure across the community. In Web 2, if you're not paying for the product, you are the product, and it's an expensive infrastructure to run, so you need to be worth a lot, and that business model doesn't translate to a lot of innovative ideas. Web 3 distributes those infrastructure costs along the community. People who have, say, a spare desktop and a spare internet connection can hook it up and then provide resources for people running local backends. And it really, at that point, becomes an incentive issue. And that's where the token economics comes in, is to solve those incentives and align those incentives correctly. But to bring this all back to ipfs-bch-wallet-consumer, in part 2, I showed how to configure it to connect to different Web 2 and Web 3 connections. And among those, the default connection is free bch.fullstack.cache, our free Web 3 connection. I'm going to show you how to set up your own local copy of that today so that you don't have to depend on fullstack.cache being available or one of those other alternative endpoints that I pointed to. You don't need to depend on those being available. You can spin this up on your own local machine anywhere in the world and access a global backend over IPFS. And so let's get into it. So I've already talked about psf-bch-wallet. Now I'm going to introduce ipfs-bch-wallet-consumer. This effectively is the local backend. So if we go back to this image here, ipfs-bch-wallet-consumer is the local backend. It's the one piece of software that makes up the local backend, and it bridges IPFS, and it provides a REST API for psf-bch-wallet to talk to, which is running BCH consumer here, which is a JavaScript library. And so what you want to do to get started with this is go to the ipfs-bch-wallet-consumer repository on GitHub and clone it like we did before. So here I am on the virtual machine in the wallet from the last video. I'm going to git clone the consumer repository. And unlike, this is written in Node.js JavaScript, but we're not going to run it that way. We're going to run the Docker container. So if we go into production, Docker, there is a Docker compose file. And so I'm expecting that you've had Docker and Docker Composed installed. And again, if you do not, you can go to the psfoundation.cache/video page. And I am referring to this video right here, setting up a new server. This will take you to a gist and show you how to install Docker and Docker Compose and Node.js on an Ubuntu system. So I'm expecting that you have this available. Here are the versions that I'm running. And so these are all images, so the first step is to pull the images down. And this will take a minute while it goes out to Docker Hub and pulls down the precompiled Docker images. You can always compile from scratch, but this is the easier way to go. So that may take a minute to download, but once it's done, it'll look like this. And so we've cloned it, we've pulled the Docker images, and now we can stand it up with Docker Compose upd. And so this will run them in detached mode or daemon mode. And so there's 3 containers. One is MongoDB. That's not really used. There's ipfs-bch-consumer, which is an IPFS node. And then there's bch-consumer, which is the actual code in this repository. So the first thing to check the first time you bring them up is check the IPFS node, because if that's not happy, nobody's happy. And so let me just walk through here. You can see I'm using version 13, which is the latest as of this recording. It created a new ID, and I mounted a swarm key, so all of the PSF stuff, IPFS stuff, happens on our own private network. And so you're looking for this. This should all happen automatically. And then daemon's ready, and it'll just hang out like that. And if this all looks like this, then the IPFS node is all good. And now you can check out the BCH consumer container. And I'm actually going to scroll up to the top and just point out a few things that you want to look for. So it looks like it failed the first time it started because it was trying to start up too soon. The IPFS node probably wasn't ready, but here's what it looks like when it's successful. It runs on port 5010. That'll be important in a minute to know that. And it's subscribed to some pub/sub channels. These are the 2 bootstrap nodes, so if you see success here, that's great. That means you're really doing good. If you don't, it's not a big deal. It downloads a bunch of other circuit relays from a gist on GitHub, and we'll try to connect to those as well. And then here is a message where it says it found a wallet service, and here it found a pay-to-write database service to connect to. So this is what success looks like. And it really should just be that easy. It should just be these commands: docker pull, docker upd, and then check the logs. Okay, so, and then if you do docker ps, you can see the 3 containers that are running. There's BCH consumer, IPFS consumer, and MongoDB. So to stop these containers, you can go docker compose down, and that would stop the containers and remove them. But I'm not going to do that right now. The main thing we're focused on here is BCH consumer, and we can see here it's running on port 5010. So with that running, I'm going to go back to psf-bch-wallet and look at the conf file. So I have the REST URL set for this local machine from part 2. I'm going to change that REST URL to localhost port 5010. So that now the wallet is going to talk to the wallet consumer app, the local backend. And also I want to make sure to change this interface to consumer API. There we go. Okay, so now we've got it configured, and there's a few commands I want to show. So I already pointed out the conf command, how to configure it to talk to your local service. There's this wallet service command. So if I do help to bring up all the commands, there's wallet service and wallet service test. So if I go bin run wallet service, this will list all the global backends that our local backend can see on the IPFS network. So there's several of them, and people who run these tend to tag them with their geographic location, because the closer one is physically to you, probably the better the experience will be. So there's one in Chicago, there's one in British Columbia, Canada, one in Portland, Oregon. This is in the USA, but doesn't really say where. And then Decatur BCH Wallet Service. This is one I run locally here, and so I'm going to go ahead and connect to that one. And so if you do the help for that wallet service command, there's a -s argument where you can tell it which one in the list you want to connect to, and you give it the IPFS ID. So I used psf-bch-wallet to control my local backend and tell it to switch to my desired global backend. So you already can see how this, now you're kind of a power user. You have many more options. If one of these isn't working, you can just look up another one to use. And if a new one enters the network, it'll pop up in that list, and you can connect to it. So if I run that wallet service command again, I can see if I'm connected. Okay, it usually takes a few seconds, which is why I waited. But so this confirmed that I am in fact connected to the global backend on Decatur. So if I go wallet service -test, it'll run a basic sort of end-to-end test. It's sort of kicking the tires and making sure that this backend that I'm talking to is fully functional, that it not only is the full node working, but the indexers are working, and it can do all the things that that the wallet app needs. So so this is what success looks like. This is it. Tested it, looked up a wallet balance, checked the Fulcrum indexer, tried to broadcast a transaction, tried to look up a public key on the blockchain. They all passed. So that's great. And so those are the wallet service commands. So that's basically how you can see how this would be handy if free bch.fullstack.cache is down, which it is occasionally, it falls over. You can use this to connect to an alternative service like I showed in part 2. But maybe there's a crackdown in the future, and it becomes illegal to host, full nodes or something like that, something weird like that, or maybe you're in a country where, something like that is going on. This is a way for you to find things over IPFS, which again is much more censorship resistant than everything about it, and it comes back to this content addressing. You don't need to know where these people are or who they are. They're providing a backend. You can test it to make sure that it works. It's free. There's there's nothing that they can sort of take from you. You basically just need this access to the blockchain, and these indexers and these other people, these other community members are providing that. And so it's much more flexible. And to get even deeper into some of these commands, there are these IPFS commands I want to show, because we're actually running an IPFS node in our local backend. So there's these IPFS commands that let you interrogate our private network here and see what other peers are on the network, what other circuit relays are on the network. Circuit relays are a really important concept that cachestack.info talks about. And so if we go bin run IPFS peers, oops, this will list all the other IPFS peers on the network that our node can see. And again, this is a private network, so the list is not huge, but it's just sort of interesting to look at. It's not really, it doesn't impact the ability of the wallet here, but if you really want to start getting deeper into the networking side of things, this is useful information, particularly for like debugging. If you can see other nodes on the network, then things are going good. So it found 13 peers here. Another one is relays. Circuit relays are really important, and they're the heart of the censorship resistance. And what you'll get here is actually an ordered list. I'm going to scroll to the top, because what the node here is doing, this is part of the IPFS chord library that I wrote that it's running, is it's actually constantly looking for new circuit relays that it can connect to, because circuit relays allow it to talk to other nodes that it normally can't talk to. And it's constantly measuring the latency between it and any circuit relay it finds on the network. So these are latency measurements. So this is the circuit relay with the lowest latency for this node, which is usually based on geography. So your mileage would vary in different geographies. And so it looks like a lot of these other circuit relays, it sees them, but it can't really talk to them, because I'm not seeing a lot of latency scores. The array is 0. But anyways, that's how that works. And there's one other one. Oh, IPFS status. So bin run IPFS status. This is just the status on this node. It gets you your local IPFS ID, the multi-adders that it's telling other nodes, like, hey, you can connect to me this way, which actually they can't because I'm behind a firewall. But this is why the circuit relays are important, is they punch holes through those firewalls. Also, it's running IPFS chords, so every node gets a Bitcoin Cash address. This is what controls the end-to-end encryption between two nodes running IPFS chord. It says, it's got this many peers. It knows about this many relays. It's not necessarily connected to that many. Okay, so I would encourage you from here to read the README. There's lots of good info here, and also read cachestack.info and understand how this is all connected. Again, these two libraries, Minimal SLP Wallet and BCH-consumer, these are part of psf-bch-wallet, our command line wallet. That makes up our front end. We just set up a local back end, and we're controlling it with the command line wallet. Our local back end is transitioning the IPFS network to talk to a global back end, and each global back end is running this back end cache stack.